Reflection is nothing but 180-degree rotation at axis. Reflection is normally nothing but a 180-degree rotation through some axis. Reflection is normally done through x-axis, y-axis, y is equal to x-axis, etc. or y is equal to y minus x-axis. Now we are going to see it with example directly, the reflection. For that, I draw here one triangle. Okay. So here I consider a triangle DEF. I consider here a triangle DEF. I write here the values of the coordinates xy coordinate x1 y1 x2 y2 and x3 y3 as 8 minus 1. No, sorry, it is 8 1 8 1 7 3 6 2. I draw that triangle here DEF 8 8 1. It is somewhere D. Then E 7 3 7 3. It is E. And F is 6 2. 6 2. F. So this is our original triangle. We are going to rotate it, reflect it first through x-axis, y-axis, and y is equal to x or y is equal to minus x-axis. So first a reflection, first case, reflection through x-axis. Reflection through x-axis. For that, the transformation matrix is T is equal to the transformation matrix T is equal to reflection through x-axis. So it is 1 0 0 minus 1. So I put this D value A, B, C, D. Among that, the off diagonals are 0 and in the diagonal A is 1 and D is minus 1. Now in this case, put these values and calculate the new triangle. Suppose I write here D star, E star and F star is equal to 8 1 7 3 6 2 multiply with this transformation matrix 0 1, which is equal to 8. Y value becomes minus, correct? Why? Because D is minus 1. So all Y values, Y1, Y2 and Y3 becomes minus. Draw this triangle here. Okay. What is this? D star, E star and F star? 8 minus 1. 8 minus 1. It is somewhere here. That is D star. Then 7 minus 3. That is E star. And 6 minus 2. It is here somewhere. F star. What do you observe here? It is the reflection through x-axis. You can observe here the reflection through x-axis with this transformation matrix T. Similarly, now we see another example. The case number 2, reflection through y-axis. So what we need to do here, if we want the reflection through y-axis, then we need to make the x coordinate minus 1 or make it minus. So the transformation matrix for this T is minus 1, 0, 0, 1. Now A becomes minus 1 and D becomes plus 1. Put this value and find out another. I give the D dash, E dash and F dash the name to these coordinates. Multiply this original matrix 8, 1, 7, 3, 6, 2 with this transformation matrix minus 1, 0, 0, 1. What happens here in this case? All x coordinates becomes minus. So it is minus 8, minus 7, minus 6. Y remains as it is. Now I draw this here. Okay, I will draw it here. Minus 8, 1. Minus 8, 1. It is somewhere D dash. Then minus 7, 3. It is minus 3. It is here. E dash. And minus 6, 2. Somewhere here. F dash. Okay. I join this like this. What happens here? This transformation matrix, this transformation matrix, what it perform? Reflect it through y-axis. It perform reflection through y-axis. Next example or next case is reflection about the line y is equal to x. Case number 3. Reflection about the line y is equal to x. Both are same. So in this case, instead of diagonal, off diagonal points are used. How to write the transformation matrix here for this? It is diagonal points are 0, 0 and off diagonal points are 1, 1. Now multiply it with the coordinates of the triangle. I give the name as to the T plus D superscript plus I use here the sign. The original 817362 multiply with this 0110. What happens here? X becomes y and y becomes x. X coordinate becomes y coordinates and y coordinate becomes x coordinates. That is our new values or the new coordinates 1, 8, 3, 7, 2, 6. Now I draw it here. It is 1, 8. 1, 8. Okay, somewhere here is our D plus. Then 3 7. 3 7. It is here E plus. And F is 2 6. It is here F plus. Join this. So what is it? It is reflection with the line y is equal to x. It is the reflection with line y is, or about the line y is equal to x. Now the last case, case number 4. A reflection about the line y is equal to minus x. For that, the diagonal points are 0 0 as it is. Off diagonal points becomes minus 1 minus 1. Off diagonal points becomes minus 1 minus 1. Now give here another name. What can I give here the name? Give any kind of name. T minus E minus F. Okay. Superscript is equal to 817362 0 minus 1 minus 1 0. What happens here? X coordinate becomes y coordinate becomes x coordinate, but the minus sign is assigned to everywhere. If we put this here, I'm not going to draw because here already written. What is it? Minus 1 8, or I will draw it. Not such a space available, but I will write minus 1 minus 8 1 minus 8, it is here. Then minus 3 minus 7, E minus, and minus 2 minus 6. So it is reflection about y is equal to minus x. It is reflection about y is equal to minus x. Is it clear? So first see once again in short. If we want to perform the reflection of an object through x-axis, y-axis, y is equal to x and y is equal to minus x, then there are the standard transformation matrices for this. The first one, for reflection through x-axis, t is equal to 1, 0, 0, minus 1, where we are going to make y as a minus value. And that's why d is equal to minus 1. We will get this result, and this is the first result. Reflection through x-axis. Then reflection through y-axis, where we make a as a minus 1 and d is equal to 1. Then we will get this result. Okay. We will get this result. Reflection through y-axis. Then in reflection about the line y is equal to x, here the diagonal points are 0 and off diagonal points are 1. Then we will get this result. Okay. And when y is equal to minus x, we will get this final result. Now, if we find out the determinant of all these matrices, all these 4 matrices, transformation matrices, Then what is the determinant? Determinant of all these transformation matrices T. What is the determinant here? It is -1. It is all these four. Then what is indicate that if the determinant of the transformation matrix is -1, T is -1, then it is a pure reflection. Then it is a pure reflection. Means if the determinant is +1, then that is a pure rotation. If the determinant is -1, then that is the pure reflection. Now the next point that we are going to see, combined reflection generates rotation. If we combine two reflections together, then it generates the rotation. Combined reflection yields or generates the rotation or result in the rotation that we are going to see with example. So consider the triangle ABC with values x coordinate, y coordinate values. I write it here. The values are 4, 1, 5, 2, 4, 3. Now I draw it here, the diagram of this object, the triangle. What is the first? A, 4, 1. It is A. 5, 2. It is B. And 4, 3. 4. It is C. That is our original triangle ABC. Now we are going to make two reflections. Okay, we are going to make two reflections. The first, reflect it about x-axis. Reflect it about x-axis. The original is 4, 1, 5, 2, 4, 3. Reflection about the x-axis. The transformation matrix is 1, 1, 0, 0, minus 1, which is equal to, make all y-axis -1, -2, -3. I draw this triangle here. First, I make two reflections. A star, B star, C star. What are the values? Four minus one, that is A star. 5 minus 2, that is B star. And 4 minus 3, that is C star. So you can see here the reflection about the x-axis, the first case. Second, now we reflect it through the line y is equal to minus x. This is one of the example that 2 reflection is equal to 1 rotation. Reflect it means reflect A star B star, the same one. The resulting triangle. With y is equal to minus x. About the line y is equal to minus x. The resulting A star B star, we are reflecting it the 0 0 minus 1 minus 1. Then we will get 1 2 3 minus 4 minus 5 minus 4. X becomes y becomes x, and change the sign. Plus becomes minus, minus becomes plus. That is our equation number 1, suppose. Now, these 2 reflections we have done. Draw it here. I am going to draw the triangle here. 1, 4. 1 minus 4. 1 minus 4. It is A plus. Then 2 minus 5. Something here. B plus. And 3 minus 4. 3 minus 4. That is C plus. Okay. So this is our new triangle. Now we can observe it. It is through y equal to minus x-axis. These 2 reflections we have done on this original triangle ABC, and this is the final result. Correct? This is the final result. First this reflection and then this reflection. Now we will see direct rotation. If we rotate the original triangle, original triangle ABC by an angle 270 degree. 270 degree. The results are original 415,243, and for 270 degree the transformation matrix is, now multiply it. After multiplication the result is okay. So that is the result, means the same. This same triangle is generated here. So from equation 2 and equation 1 and 2, what we observe that both are same. Both are same. Means 2 consecutive reflection may result in 1 rotation. This is one of the examples. So many possibilities or combinations are there. But this is one of the example that if we use 2 reflection or perform 2 reflection on an object, it may result as a rotation, single rotation. We call combined reflection yields rotation.